What's going on, guys? Welcome back to another Exam P sample problem from the SOA. Again, my name is Jacob Stinson. Tonight we'll be doing a problem dealing with normal distributions. So let's get started. As always, I'll let you write down the problem. So number 223 is the problem we'll be doing, and it states claim amounts at an insurance company are independent of one another. In year one, claim amounts are modeled by a normal random variable x with mean 100 and standard deviation 25. In year two, claim amounts are modeled by the random variable y equals 1.04x plus 5. Calculate the probability that a random sample of 25 claim amounts in year two average between 100 and 110. Okay, so let's pull out my handy notepad. Let's open a new page. So we're doing number 223. And the stuff we know is we know that x is normally distributed with mean 100 and standard deviation 25. And then we're told y equals 1.04x plus 5. And we're asked about the claim amounts in year two and what the probability of those are being between 100 and 110 are. So our goal is probability of 100 minus the mean of y over the standard deviation of y is less than z less than 110 minus the mean of y over the standard deviation of y. And this is for 25 observations, which that'll be key here in a second. All righty. So we need to find the mean of y and the standard deviation of y. And we also know that when you have the sum of independent normal random variables, those are also normal random variables. So y is also going to be a normal distribution. But we need to find what expectation of y is, which is our mean, and then the standard deviation of y. So we know that mu equals the expectation of y, mu y equals expectation y, which equals expectation of 1.04x plus 5. So this equals 1.04 expectation of x plus 5, which equals 1.04 times 100 plus 5. And this actually just equals 109. So for the standard deviation of y, we know that anytime you're dealing with standard deviation of variance, the variance and standard deviation of a constant is 0. So we don't have to worry about this 5. So we have the standard deviation of y equals 1.04 times 25, right? Because we have 25 observations in this case. So this is 26. Now, for the average of 25 observations, then let's go back to the problem. That's what it's telling us. It says calculate the probability that a random sample of 25 claim amounts in year two average. So the keyword here is average between 100 and 110. That is key in this problem. So the average for this problem is the key, as I said, and the mean will stay the same. So go back to our goal problem, or our goal here. So we have the probability of 100 minus 109 divided by something is less than z is less than 110 minus 109 divided by something. But we have to figure out what our standard deviation is for the average. So, as I said, for the average of 25 observations, mean is still 109, right? Because the mean is the same as the average. So obviously there's going to be the same number. And then for the standard deviation, this is what we have. And standard deviation of y in this case is going to equal square root of the variance divided by, in this case, 25. So this equals the square root of 26 squared over 25, which equals 26 over 5, which equals 5.2. That is the part of the problem that stumped me for so long. If you forget to do this problem, if you forget to do this part, you will get the problem wrong, right? And I kept getting the wrong answer. It's like, how the heck do I do this? So then, I looked at the SOA solution, and this is kind of what I was getting at. They were a lot more vague, but this is generally what they're saying. So now we have everything we want. So now we can plug in 5.2 and 5.2. And now we just do the standard z-table calculation. So this is the probability of, and this number is negative 1.73077. It's less than z is less than 0.1923. Look at your z-table. You end up getting 0.51. No, sorry. You actually end up getting 0.5753 minus, and then 1 minus this number, which is like 0.9582. So your answer ends up being 0.5335. And that is your answer. So yeah, this is a very, not a lot of computation, but it's very easy to make a mistake right here in this part. So be very, very careful to what the problem says and what it's asking. And if you do the average part right, you'll get it right. But it can be very challenging. I guess the word I'm trying to say for these type of problems. So thank you for watching, and see you next time.